Let's write some actual code. So I'm starting this series on object-oriented programming in C language. Yes, you heard that right. Usually we move to C++, Java, JavaScript, but we can do anything in C. And I'm not using AI anymore. I'm done with it. I've deleted cursor, anti-gravity. I don't need anymore. Even though I'm not familiar with C that much, but I can do a pretty good job because I can think as a human and I want to know what the heck is going on in my file directory. So, yeah, so I made this decision. I've created this series on object oriented programming, and there will be more videos like this. Usually, what happen is people start with some roadmap. This is what are the things that we are going to do in C, but fuck that. Let's start straight away with a really hot topic, which is ab- uh, abstract data type. How we can basically not care too much about the type security and build an interface for almost any set of data. So let's start with this course and let's start with very first topic, which is uh, ADTs. Abstraction is not a very new concept in programming. It's been around for so long. It was first introduced in 1970s. So in this video we're going to understand, like, doesn't matter irrespective of kind of language we are using, we basically try to normalize what is base definition of abstract data type and how we can basically carry forward that same concept in different language. So doesn't matter the kind of language you are using, basically there are two kind of data type. Very first data type is primitive data type. So primitive includes things like integer, character, boolean. So each of these type consists of set of values. For example, character consists of 256 bit and it basically depends on the hardware you are using. So there are set of operations as well that you can perform on these primitive data types, such as plus, minus, division, multiplication, irrespective of like, you don't need to understand what these how these operations are working underneath, but these are the operations that comes with language itself. Next, imagine a set of value. So now we are talking about ADTs. Imagine a set of value that basically consists of some fixed operation and which is something that language doesn't support. For example, let's imagine a complex number. In complex number, we have one real coordinate and second one is imaginary coordinate, and we can represent a complex number like uh, the real part and the imaginary part, which basically I think denoted by the iota symbol. So there are a lot of language that doesn't provide support for complex number, let's say, and there are multiple fixed operation that we can perform on these set of values. So we have this set, right? And there are operation like what is its magnitude, what's its angle, right, from x and y, and there could be other operations like I want to do multiplication of two complex number. How I can do that? I want to add two complex number. So there are a few kind of data sets where we have some predefined operation, and that's something that is not supported by language. If we follow these process where we are defining the control flow of the entire program, then it would be pretty difficult, like it would be really difficult for us to basically depend on these primitive data type. We need to define an interface. So ADT consists of few things. Very first thing is the interface, where we are basically defining the set of operations that user can perform, and we are exposing this interface to user. So user can look into the definition and they are going to perform these operations, right? And its implementation part, like, doesn't matter the number of operations you have added here, their implementation part is something that is abstracted away from user. So let's say we have implemented all these methods, then this user is not going to have access to those methods. User can just interact with the interface. So that's the concept of abstract data type in a nutshell. And this is something that we are going to implement using C language. So our motto is to basically do all the operations of object oriented programming in C, so that we don't need to depend on other language. Let's say you are really good at C language, right? You don't need to learn C++ to basically do operations in, basically do your tasks in, let's say you are really good at C language, so you don't need to basically learn any other language to you know start with object oriented programming. The implementation part is pretty straightforward. All we have is three files: the interface that user can look into, the implementation file that user doesn't have any access, and finally the main program where they can basically make use of that interface. So I have created this header file here. You can imagine it like a type definition file in TypeScript, where I have all the types for variables, for methods, for everything. Similarly, we are going to have this interface where I can define the set of value and set of operation. So I took a very simple example of a point P in some coordinate x and y. So I can create this point, move it, print, and delete this point. Very basic operations. So in this file, first I'll basically define this set like a pointer point, and it would be constant. User cannot look into it. They can perform just the operations that are defined. And I'll add one more keyword, that means it is defined in some external file. Next, I'm going to have these operations in sequence, which is user can create a new point. So here we'll add x and y. Next, user can basically move point. So we'll add the instance of the point and the x and y placement. Next, user can print point. Again, we'll pass the current instance of that point. And the final method, we want to free the memory when we no longer need that point. For that, we can have a method called delete point. So in last, like these two methods, we are not returning anything. Let me remove it. These are just methods. Okay, we have a interface ready. Next step is actually implementing it. So in this file, I'm going to implement this. So I'll basically create a structure of point where I'll have integer x and y. I might make some mistakes because I'm not used to C language. So this is something I'm exploring right now. I'm not really good at it. So let's create a very first function. And here, what we're gonna do, we are going to allocate some memory, right? So I'll create this structure. I'll create a pointer and and allocate some memory of size of this pointer, point P. Perfect. The next step would be assigning the x and y value that user is providing. And finally, I'm going to return this pointer. I guess that's all we need, right? Is there anything else we need? No, we don't need anything else. Next step is defining this move point. So move point is also pretty straightforward. All we gotta do is update the coordinates of this current instance. So here first I'll create a pointer and assign the current pointer to it so that we do not make changes directly to this, because we don't know what user is passing to us. So we are assuming that it's a pointer, because it's pretty straightforward that very first method is returning us this pointer of this particular schema. Okay. Next I'll just add this x and y to it. That's it. That's all we need in this function. And the final function is basically printing these values. So I'll call it print. I think I have misspelled it. All right. So I'll print the current coordinate of that point. It have moved somewhere in the space. God knows where. So let's print it. And say point is at x comma y and their actual value. Again, I basically had to create this structure. So why not just copy this line? So I'll provide very recent value of these coordinates. Okay, we have new point, move point, print point, and finally we want to delete that point, right? So I'll pass again its in current instance and I'll just free this memory. That's it. We are ready with the interface and the implementation. All we gotta do is just run it in the main file. So I have created this for a point. You can basically create an assignment for you. You can implement it for some user data, for some vector, or you can define your own methods like this. So here you can imagine what I'm doing. I'm creating this point, then I'm moving it in space, then I'm printing its value. Again, I'm updating its coordinate, printing its value, and finally I no longer need this point, so I'll just delete it. Okay. So currently I am in this point folder and here I have these files, right? So what I'm gonna do, I'll compile these two files. First, let me remove the existing program file. Okay. So I'll compile main.c and point.c in the program file. I hope this should work. Oh, there are some errors. Hmm, I think we need to add the standard library as well. That's what I'm assuming. Okay, let's recompile it. Oh, it has compiled. Crazy. Now all I gotta do is look into this program file. But first I wanna make sure I'm printing these in new line. I'm getting better at C. That's crazy. Recompiled it. Now I'll look into the program file. It is working, yes. Whew. So you can see here I created this point, then I moved it to some distance. Again, I moved it to some distance, and finally I freed up this space. So this is how data abstraction work. Here we have the entire file dedicated to the implementation that user doesn't give a fuck about, and all we providing user is this interface set of possibilities. So you can give yourself an assignment. You can pick some vectors, some complex numbers. You can create your own interface, and yeah, just Do whatever fuck you wanna do. So this is the first episode of, um, you know, basically bringing the object oriented behavior in Objective C. So subscribe to this channel. I'm going to upload more videos like this.